All right. Let's check the recording. Yep. Okay, so the focus of today's class is really the heart of our whole topic on data analysis. You spend a lot of time doing dot plots, stem plots, frequency tables. You've done that since year 7, probably. Finally, we're going to do something that's a bit different that you probably haven't seen before. If you did year 11 last year, we're going to develop a theory behind it this year. So, what we're talking about today, if you forget everything, remember this picture. I've got numerical data on a scatter plot. So both variables x, the explanatory variable, and y, the response variable, are numerical variables. And what we want to do today is describe how we might fit one line, a straight line, to model the data. So right now, I'm not entirely sure how I'm going to do this, but I've set this as the goal. I want one equation with an intercept, which we call A in this class, and a slope. Previously, you might have called this the gradient. So just note the difference between mx plus c and ax and a plus bx. Here, a equals c and b equals m. So in general maths, we use this form. I think it's confusing, but you'll just have to get used to it. So a for the intercept and b for the slope. So in year 10, you use mx plus c, right? You use a plus bx, is that right? It was VCAR's decision, not mine. I don't agree with the decision. Now, so is the goal clear? I've got some numerical data. I want to fit one line to model the relationship between the data. So this happens all the time in science, engineering, finance. Whenever you've got numbers for two variables, we're always interested in how we can do this. All right? So today, I'm going to give you a formula for A and B and the theory behind them. And we will also get these using CAS. So is the goal clear? You know what we're trying to do. So if you did year 11 last year, the calculator gave it to you, but I didn't explain where it came from. This year, you're expected to understand where it comes from. So this is new. So I don't think any of you will have learned this last year. So please write this. So please get this diagram down. Okay. So what we're doing here is we are assuming we have picked A and B, where A is the intercept and B is the slope. I haven't told you where it's come from. That's coming in a moment. The equation of this line is y equals A plus bx. I'll just add one more point for clarity. Now, what's the residual? Can you see that here, it's not possible for me to draw a line which passes through all the dots. It's just not possible. We can't do it. So we've got to pick it somehow. And the way we're going to pick the line is we're going to use something that's called the residual. So I'm going to draw an arrow here. Now, let's imagine I'm just going to call it xi, yi. That might confuse you. The reason is because there are endpoints, x1, y1, x2, y2, etc. Okay, so I'm not referring to a specific point, I'm just referring to any points. And I'm giving it the name I for the moment. What I'm seeing here, and I hope you're seeing this too, is that there is a difference between the actual y value in the data and what this straight line is predicting from the data. So this is something that our Year 12s last year had trouble grasping. So I'm going to write it out in words, and maybe this will help. So the line gives us a prediction for y at every value of x. Okay? Now, the actual value is the value of y at the coordinate. So I'm going to call that yi. Okay? So given any point, there's going to be a prediction for that x value and the actual y coordinate. So I'm going to call the actual value yi here. And I'm going to call the predicted value what this is here, this point here on the line. So it's got the same x value as the data points, but can you see the y value is different? It's going to be off because there's too many points to fit a perfect line. Now, a question we need to answer is, what is the y coordinate here? So I'm going to remind you, the equation of this line is y equals a plus bx. What are the coordinates going to be here? Has the x value changed? Can you see that? I'm at the same position horizontally along the x-axis. So the x value is going to be the same. The y value is going to be different. I need to write the y value in terms of a, b, and xi, my chosen value of x. We need to use the S word, substitution. Okay, so I'm just going to give it to you. If you're not sure where this came from, you substitute x equals xi into y equals a plus bx. So I've changed x to xi. So the coordinates of this point are a plus bxi. Is that okay? You're very quiet, so I'm a bit scared. In any case, this is going somewhere. The key thing I want to draw your attention to is that every time I have a value of y, when I fit the line, I have a corresponding prediction for the value of y at that value of x. And it's generally going to be a difference. This difference is what we call the residual value. And we define this to be the actual value minus the predicted value. This equation, written in words, is given to you on your formula sheet at the end of the year when you sit your exam. Right? So I'm going to write something in words for you here. The residual is a measure of what we will call the error between the true value and predicted value at a point. I'm already feeling that this is a lot heavier than the last few weeks. So, I'll just give you a few more seconds to keep writing, and then I will try to summarize the last 2 pages in a few sentences. Once your hands are finished, I'll continue speaking. Question? Yeah. Yes. What influenced you to become a teacher? What influenced me to become a teacher? Like you were working in the statistics. Mm-hmm. Were you making more money? Yeah. That's really good. Like a lot more? Because I know how much we have to a range, which is shit for your brain. But like, what influenced you? So what made me want to become a teacher? Well, I had good teachers when I was at school, and I had good relationships with my teachers. And I think my teachers made a big difference in my life. So they influenced me. So they have always commended the teaching profession to me and the impact that an adult can have on children and teenagers. So you're just a good guy. I think you've got to like learning, and you've got to like seeing other people learn as well. And I actually think teaching is a lot of fun. And it's not just about the content, right? It's about the relationships. So I can have some banter with you, joke around. It's great. Hmm? Yeah, exactly. And the reason why I tell you to sit down and do your work is because I want you to have as many opportunities as you can to do this. And that's why I'm going to do the work on. In. Mm-hmm. I did think like the exact way you told us to do it with the formula, and it's like significantly different than the answer. Okay. And I even looked at the example that it has there for answers. Okay. Well, there might be an error, so we can check that later. Okay. Just move on. Okay. So let's bring it back, guys. I know I've presented a lot of content, so let me give you the big picture. Here's the picture. Number one, we are trying to fit a straight line to data that's messy. Number two, once I fitted the line, and I don't know how I'm going to do that yet, but if I have fitted the line, there's going to be error. That error we call the residual. Is that okay? Yeah. Picture, residual. Now we're going to put them together. No, not that. Need to come back to that. So, this is called, there are many terms for this. I'm going to call it linear least squares regression. We did that last week. We did. Okay, so I'm finally going to tell you, those of you who did year 11 with me, where A and B come from and why we choose certain formulas for them. So, you've got the scatter plot. You've got the line. You've got y equals a plus bx. How on earth do we choose this? Here's how we do it. All right. For each point, xi, yi, the reason why I'm using I is because there could be any number of points, okay? N points. For each point xi, yi, define the residual di equals the actual value yi minus the predicted value a plus bxi. See the previous page. Okay, so if you're lost, this is exactly the same as the previous formula. Residual value equals actual value minus predicted value. This is, yeah. I will show you something crazy at the end of the class if you like. But you don't have to learn it. Okay, it's just for you to admire. Okay. All right. So here is how we choose A and B. By making the sum d1 squared plus d2 squared all the way up to dn squared. So here there are n data points in my scatter plot. I know this is like, where the heck is this coming from? So I'll explain it. D1 squared plus D2 squared. Do it for every single data point. Take the residual and square it and add them all up. We call this is important, so I'm going to give it a different color. Minimizing. Those of you who have calculus in your ears, that should ring a bell. Minimizing the sum of the square of the residuals. Yes, you are expected to know that sentence. Okay, so take a moment to get that down, and I will discuss it with you. What's up, Jason? Sorry? Okay, we are almost done with the theory. In a moment, I'll give you a formula, and we'll only do it on the CAS calculator after this. So if you're crying on the inside, the tears will end soon. I promise you, this is the heaviest class this year in terms of gear.
This is the hardest thing.
This is the heaviest class in terms of theory. Conceptually, there are things more difficult later in the year, but in terms of theory and abstractness, this is the top of the cake for this class.
Okay, thank God.
Okay. All right, let's talk about this purple text here. So, for every data point in my scatter plot, there is a residual. A difference between the actual value, which is on the scatter plot, and the predicted value, which is on the line. This difference I call the residual, and what I'm going to do is I'm going to take every single residual, then I'm going to square them, then I'm going to add all those values up, and I want to choose A and B so that this sum is as small as possible. Now, there's a few questions that I can anticipate. Why didn't we just choose D1 plus D2 plus D3 all the way up to Dn? Why did we have to square them? This seems to come from nowhere, right?
Yeah.
Okay, so if you don't square them, this actually turns out to be 0. Now, yeah. So if you don't square them, this summation adds up to 0. That's an exercise I would give to a first-year university student to show that. Okay, so you don't have to do that. All right. The other thing we could have done is we could have just changed every negative number into a positive number. The problem with doing that is you can't apply calculus to a non-differentiable function. So when it's squared, you can do that. So it just turns out that when you square it, it's easy to solve this problem. Okay? When we do this, we get nice formulas for A and B. Yeah, so you need to square the residuals. Okay? We want to square the residuals, we want to add them all up, and we want to make that sum as small as possible. Okay? We'll do an example of that, Tom.
Please do.
Yeah. Okay, so here's the punchline. If you do all that, we obtain the following formulas. So here are the formulas for A and B. These are given on the formula sheet at the end of the year. You are expected to know them, but most of the time, you will just use a CAS calculator to get them. But here are the formulas. B equals R, the correlation coefficient, that should look familiar. SY, the standard deviation of Y, divided by SX, the standard deviation of X. Okay, so you've seen these three numbers before. Turns out, if SY. Standard deviation of what? So there's two numerical variables. So you need to take the standard deviation of one variable, standard deviation of the other one. Okay? So, turns out you need to calculate B first. Once you've got B, then you get this. Y bar minus B X bar. Okay, we need to do an example now. Now my textbook's being used, so I will screenshot from my computer. Is anyone still writing? Okay, I'll let you finish first. I can give you one. It's alright, no worries, because I still need to screenshot from my computer. No, I want to like screenshot it onto here. Yeah, it's alright. Okay, so I'm going to do question 5 from 3A with you. Okay, so guys, let's actually practice now. We're going to use these formulas. Most of the time you won't, but occasionally a multiple choice question comes up that requires you to know these formulas. You'll see that in the booklets for past exam questions. On the formula sheet? Yes. But a lot of students don't realize these formulas exist because they forgot. Oh, thank God. Does that mean I can forget it too? No, that means you need to know them so you don't get destroyed on the exam. All right, so everyone listening, please. Tom, thank you. So, in this question, we are using pollution to predict. No, we are using traffic volume to predict pollution. Okay, so what's happening here is I want to write y equals a plus bx, where y is the response variable and x is the explanatory variable. Okay? Now, can you see they've given us the information we need? They've given us the mean, they've given us the standard deviation, and they've given us the correlation coefficient. All things that we need to find out A and B. Okay? So it's a simple matter here of writing down Sx,
Standard deviation of y.
Sy,
Oh,
X bar, Y bar,
that looks quite easy, really.
plug and chug into the formula.
What did you say?
Plug and chug.
Never heard that before, but alright.
We said it all the time when I was at school.
I've never heard that before, and I don't think I ever want to use it again.
Probably not.
That's fine.
Okay, so have a look here. We've got two standard deviations. Which one's going to be the standard deviation of X?
97.9.
Because pollution level is the response variable. So remember, hang on. Traffic volume is the explanatory variable X. Pollution is the response variable Y. So if this is a multiple choice question, they're going to set up the options so that you mix up X and Y and you'll pick the wrong one.
That's fine.
But
Not even an issue.
you'll get 0 marks though, even though you understand this. Okay, I know I've done that a bit quickly, but hopefully you can see that from the table. X in the first column, Y in the second column, means in the first row, standard deviations in the second row. X bar, Y bar, SX, SY. Alright, can I leave it with you to plug and chug?
Yeah, I've done it.
Because you can do this, alright?
You can do it.
Yes?
I what it was. It was a big typo.
Okay.
They got the numbers changed.
Yeah, okay.
Because I switched the standard deviations and I got the numbers.
Yeah, okay, cool.
I know. I know.
Alright, get your task calculators out, folks. We're going to do this on the cast now.
No.
Most of you have already done this before. But if you were in microeconomics class last year and you have yet to produce the summary statistics for various numerical data,
Is that the A plus BX?
that's it. So,
I don't know. I mean, no one
yes. Go get your CAS calculators. They need to come to a maths class.
Oh, fresh kicks. Nice.
Ah.
You took the words right out of my mouth.
See? Maths. Alright, can you see that? No.
Oh, no. Dude. So you hate
This.
Yeah. Oh, no,
Do you hate maths? Man, who wrote that? What's the person wrote something plus assignments? You hate maths.
Is it you?
No, it's like
You tell us something? I reckon just leave the lights on.
Leave the lights on?
Yeah. It was clearer.
Okay.
No, oh no. Oh no, that's so much worse. Oh no, man. There's lights off.
I vote lights off. You know, I could avoid this problem by buying my own CAS calculator for $200, and then I could buy the electronic software. Is it worth it?
Well, if you keep texting
Yeah. Because the school ones, right, like the license has already been used, so I can't download it. Is it worth it?
Yeah.
No, really not.
I'm not gonna make them like any money.
for 2 years.
The lawyer.
Don't you just claim that like a tax for
I'm reducing my taxable rate. It'll have to do, I think. But I think we will live with that. Okay. If you've never done this before, please follow along very carefully. We are doing linear regression. Okay, so you want to go to New Document from the main menu. And when you get the option, you will want to select option number 4, Lists and Spreadsheets. So I'll write this on the whiteboard for you. Alright, so do that. Okay, you need to give your data some names. So because I'm so creative, I'm going to call column A EV and column B RV. Alright, for explanatory variable and response variable. Name your columns. Okay, we need some data now. So I've already created some. I'll write this on the board as well. So keep this data because we're going to do a calculation with the residual afterwards. Life would be so much easier if we could just take Excel into the exam, but no, we have to use these overpowered bricks called CAS calculators.
Sean just taking the room. Surely I just make it as calculate. Excel comes out. Just Excel.
Just a calculator that runs Excel.
If it's based, another A.
So please take a moment to type in the data. The data is here.
Yeah, we'll take the textbook into the.
I told my class last year that if they took a textbook into the exam, I'll be very disappointed.
So you just wanted to name it.
Hmm? No. If you took your textbook in, that tells me you did not bother to prepare for the exam. I'll be furious. I'll keep a straight face because I don't want to stress you out for your exam. But I'll
rephrase that. Can you get spanked?
We don't live in the 70s anymore.
Damn it!
Corporal punishment is out. Besides, I never do that to you. Okay, so the exact number doesn't matter. The point is you've got data in both columns of your spreadsheet, and now we're gonna get A and B. All right, so here's how you do it. Menu. Statistics. Stack calculations. It should be very familiar if you did it last year. And number 4, linear regression. A plus bx. Type in the names of your x and y variables. So I named them EV and RV.
Oh, yay.
All right, and once you've done that, you get A and B. Okay? You're going to do this many times this year. You will do this several times on the SAC and probably several times on the exam.
7.
Several.
He's got it every single time.
7.
Okay, so you need to do this so many times this year that this is just in your muscle memory.
Yes.
A new spreadsheet. Enter the data, name your columns, menu, statistics, linear regression, A plus BX. And you get A, B, and you also get R as well, and R squared, which we learned about last week. Okay? All right, so this is probably the most important part of today's class, actually getting the values of A and B from raw data. That's probably the most common application, and the main one on the stack as well, which is in 5 weeks.
How much is going to be on the stack? Like which chapters?
The whole thing. I'm testing everything.
The entire textbook.
Chapters 1 to 5 in 5 periods.
Oh.
It's a 5-period sack.
Wonderful. Wow. That's a lot of content.
It's a big sack. So
Is it the only stack that we have for the whole year?
no.
Damn it, Mr.
We have 3 more sacks after that, but those are only 3 periods long.
4 stacks all total.
14 periods of sacks during the year.
Is there, like, because it's 5 periods long,
Yes?
is it testing a chapter each period?
Not exactly.
Damn it. I was going to say, I could just study up on the first chapter.
You can do
Study
it.
each chapter individually. Study each chapter just before I go.
No. So Kai, you can't do that because sometimes I will require you to draw elements from multiple chapters into the one question.
That's great.
No?
Go, Power Rangers.
Dun, 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 dun. You know, for a long time, I didn't know that Power Rangers was originally from Japan.
What?
And then I was like, oh, no wonder it was so good. Because I came from Japan.
Oh, you're my favorite. You guys can
All right. So, this is the last example, okay? The suffering is almost over. We can go back to less difficult mathematics in the next lesson. So, we found the least squares. Remind me to do assumptions. I didn't do assumptions. Just remind me, please. So, if you do this on the CAS, as I just did, is y equals, I did it in Excel, so it is 0.8553 plus 45818x. And here's our final example for today, okay? Can someone give me the time, please?
It is.
Okay, we're doing well. So you'll get a full period to work on this. Okay. Okay. So hang in there, year 12s. We're nearly there. Calculate the residual for the points 1, 4. So a while ago I gave a definition for the residual. Now we finally have formulas for A and B. So now we can actually calculate the residual. And this is asked on the exam. So recall the residual value equals the actual value minus the predicted value. Okay, so if you forget that, it's on the formula sheet on the exam. What is the actual value in this instance? The value for y at that point, which is
4.
4.
Yay.
Okay? So I'll write underneath the value of y at the point. Now comes the trickier part. What's the predicted value here? We're going to have to calculate it.
6.
Where did the 6 come from?
Where do you like?
So we can do better than just throwing out random numbers and hoping that they're right.
That'll be 5.
It's not 9. 9's too large.
8.
You're just throwing out random numbers. Okay.
Is it 5?
All right, let me take you back to the picture. Pictures are always good. So this is the situation we've got. We are here at the point 1. We are at the point 1, 4 on this scatter plot. All right, are we above or below the line? We're below. So it's actual minus predicted. So it's 4 minus some number that is larger than 4.
So
It's going to be a negative number.
5. Negative 5.
No, it's still guessing.
Negative 7.
Negative 4.
Is it higher than 5? Is it lower than 5?
Okay, so let me draw a picture here. This is what we've got. We've got a line and we've got a point below the line. The coordinates of this point are 1, 4.
And that's the actual value.
Yes, the equation of this line is y equals 0.85, I'm just going to round to 2 decimal places, plus 4.58x.
So,
Yeah. So the coordinates of this point are 1, 0.85 plus 4.58. Right? I've substituted x equals 1 into this equation here. All right. So that should be 5.43. So in orange, I will write substitute x equals 1 into the regression equation. That's what I've done here. We're still not done. We need to evaluate this number, minus 1.43. So if your point is below the line, the residual will be negative. If the point is above the line, the residual is going to be positive. Okay?
is there a quicker way to do it?
No, you have to substitute it into the equation. There's no quicker way to do this, unfortunately. Every time your equation changes due to the data, you have to redo this calculation. Okay? But remember, the CAST calculator gives you this. It gives you A and B. So you just need to substitute. It's substituting a value into a formula. Okay? We started off year 11 with that. So you can do it. Is anyone still writing? Okay. 3 dot points and then we're done. You've done well. You know, period 3, I taught a year 7 class as an extra, and now I've gone all the way to like a very heavy year 12 class.
What did you do in year 7?
I was just problem solving by drawing a picture.
Yes.
I can show you if you like. I've got the PDFs. All right.
Reduce the heaviness by showing
Yeah.
us, like,
All right. So to finish, assumptions when doing linear regression. No. I've got it saved from before, so I'll just show you that. Okay. Yes. Yes. Okay. Now, believe it or not, you are statisticians. You are young statisticians, but now you have the power to model linear relationships between numerical variables. With that power comes a responsibility to only do this when it makes sense. So we've got to make some assumptions before we do this, otherwise, garbage in, garbage out. Okay? So the first assumption is the data is numerical. That might seem trivial, but you will remember a quiz question where there were postcodes. And those look like numbers, but they're actually categorical variables. So your data needs to be truly numerical, otherwise you're just producing a joke. The second assumption you're making is that the relationship is linear. Or I should say the association is linear. Yep. One more dot point, and then we're done, okay?
You said 2 dot points.
No. So total 3, and we've only got 1 left.
Okay, go.
Okay. Right. So obviously, this is curved, right? That's parabolic. That's non-linear. So you can't. So don't fit a straight line to this. I will be very angry at you if you do. Okay. And the last one is there are no outliers. So something very interesting happens if you have an outlier. We might do a demo of this later. So see, I've got some really nice data here, and I've got an outlier. If you do this, this is going to happen. It's garbage.
That's silly.
Okay, so you can't. No, it's not. You fitted data to data that is linear with an artifact that's non-linear. So you can't do this. Okay. I know this sounds trivial, but these mistakes are made all the time by scientists because they just blindly apply models without thinking about the ramifications of them. Okay. All right. Well done on getting through a whole period of theory. I will upload this to Teams now so that you can access it on your laptops. A brain break is in order. So I will put it on Teams. You may now have a brain break. And once you're done with your brain break, you can start exercise 3A. Yes, bathroom breaks are fine.